Welcome back to Professional Perspectives. I'm Aro, joined by my co host Praneeth. In this three-part conversation, we're talking with AI researcher and scientist Mr. Varun Prashant Gangal about the evolving landscape of natural language systems.
If you haven't heard part 1, go back and check it out. We explored Mr. Gangal's early research and his path from academia to industry. Today, we'll dive into how evaluation and alignment actually happen in practice and why they matter more than ever in today's AI ecosystem.
Yeah, like okay, so I think to contextualize one thing, yeah, one reason people pay so much, and you will see this is typically often given for research scientists who have worked like maybe 5 to 7 or 5 to 8 years, and maybe like are around the 30, 31 to 38, where like just the right age where they have worked in at least one or two large efforts at training LLMs before. So what has happened? I mean, okay, so the reason I think a lot of this will depend on how fast the gap between the open sourcing of data mix creation, benchmark creation, post training methods, pre training methods, how fast that knowledge propagates to the wider community. Like currently maybe the gap between uh frontier LLMs and like this gap is itself unknown, because we don't know what the frontier LLM, like we don't know what Gemini 2.5 Pro really did, right? So what we don't know what they did, and we actually, like, it's both white swan and black swan. Like they we know they did some certain things. There are certain things that they did which are not visible, which we might not even know. So there is this whole maybe say 5 or 6 month gap in terms of knowledge and skill. So and what often happens is, because the AI and LLM community was this very closely knit community of physicists, mathematicians, computer scientists who thought in a certain way and worked on used to publish at the same set of 10 conferences, often you can reliably bet that someone who has worked long enough at, say, like Anthropic or Google DeepMind plus OpenAI 3 years each, they would have roughly gained the same, like gained enough insight. Like you can people are reliably given enough given enough compute resources and mandate and pressure to work on LLM efforts. People are discovering things, and you can kind of reliably bet that enough of them, when left in seclusion, will discover these things in parallel, and you will also find out from their model releases. So if you are trying to put together a new LLM lab or something, like for example, if you are, say, a billionaire, or you are the ruler of a country or something, and you want to do this, so then if you want to very quickly put together and okay, so that another reason people are paying these amounts is that uh, a publish it, like since it became kind of a, and I think I wouldn't say like since it became fashion, like when things used to be, I would say until 2021 or 2020, the AI and ML community was fully open source, like not just open source in terms of code, but like open knowledge, literally. So because, like, you can see this from the way Transformers was published, T5 was published, BERT was published, GPT-2 was also published, and OpenAI was actually called open, like also had this kind of ethos back then. But then what happened since then was actually people working on these efforts. That's why a lot of people in the open community and who are outside of maybe the larger labs, they really value the Llama 3 tech report and the DeepSeek R1 tech report, because it kind of is like someone revealing them to the knowledge of agriculture or something like that. Like a lot of things which were hidden up inside like these kind of settings came to the fore. But there's a lot that's still hidden. And one more thing is that there is a compute bottleneck on exploring ideas itself. Like if I want to, for example, explore some idea where I'm coming up with newer environments, and models are like where I want to come up with, where if I want to come up with an idea where I'm making a game, like say Prince of Persia style games which are longer, but not just for Prince of Persia but for other environments, and in a new kind of way post training LLMs on it. If I want to explore this idea, I actually need maybe because there what happens empirically is if you're running an idea, there are a lot of other factors that you need to try out to actually validate. Like you actually need to run maybe 48 ablations to see evidence of your hypothesis, and then 48 ablations of your baseline. So what I would actually need is maybe 20 A100s all to myself for the next 2 months. And uh, I would you so you need an organization with those resources, and also an effort where there is an excuse and a leeway for an employee to do this in a way that is beneficial. So these incentives only arise at so it's not so when you're hiring someone, it is this knowledge. And another thing is that uh, LLM, both new LLM family pre-training and post-training, and also I would say just simple post-training efforts. Like for example, what news research does, these also are kind of like what do you call it, wars in some sense. Now, what I mean by war, not wars like wars, or like automobile. Like when a new automobile is being launched, like many teams are working together on like kind of maybe 10 or 20 different versions of an artifact, and coordinating their timelines and versions, and like trying out their variations, and then figuring out which variation is stable, and then communicating it upstream. So you need a lot of discipline. And frankly, the human beings ourselves are a bottleneck. Like how many experiments we launch, like if you collect resources, a new pressure becomes like, if you for example you buy 30 GPUs and put them in a data center, now the pressure is on you to keep these guys efficiently occupied. So you as a team need to as a team need to balance, and like different teams need to explore and then coordinate. So it takes a lot of discipline, both yourself and in terms of how you talk and marshal resources, both as individual level, and at maybe maybe people who are like in a mix of execution and kind of managing. It takes a lot of acquired discipline to work in this kind of setting, because what can happen is, for example, if I am in the mathematics post training team, and the mathematics post training team got a version of the model, and we were, for example, exploring say linear algebra, computational geometry, and calculus. You technically, one, like if you are a little bit lazy in exploring applications, or you don't launch your experiments properly, or you kind of don't look deep enough, you do everything properly but you don't look deep enough into each ablation and figure out what works, you are kind of that one thing you did is kind of gonna hamper the okay, what did I say, algebra, like it's gonna hamper the algebra abilities of your model. And there is no, like, you are literally the only employee working on algebra. So, or maybe there is someone else in some other team like there is maybe another team working on computation, scientific computation. So if you're lucky, maybe that other guy did good enough work on algebra to cover up for your mistake overall. But it is also the case that maybe you are the only guy. So the model that, and no one has a chance to verify everything. So it's perfectly possible that you screwed up the algebra abilities of your model through your actions. So what I mean is, when you see a good LLM come out, it's because say 96 people or 144 people or whatever amount of people have worked together in lockstep and done the communication and like aggregation part and brainstorming part also, and gone through the rigor and discipline of launching those experiments on GPUs properly, and like debugging if they went wrong, and looking at the output files, and like putting those output files also back into a LLM and figuring out patterns. All that stuff they have done. So I think, yeah, I think because of the lack of publishing, which makes the code and particular tricks used, like there are a lot of, for example, when you are, for example, training a LLM, there you need a lot. What will happen is you're trying to improve it in many directions, right? But then what will happen is if a particular team does a lot of more exploration of techniques on one domain or creates a lot more data for one domain, if you train a lot on, say, math problems, what will happen is maybe your creative ability will decrease, or maybe your, because the math problems are only within a 20,000 token window, the long context abilities of your model, which at least needs seeing maybe 100K token kind of problems, those will degrade. So there are a lot of tricks around curriculum learning, for example, that are only there in, like, how to do this kind of so I mean curriculum here in a different sense, not in the sense of stacked difficulty, but how do you create a regime that mixes different abilities such that you improve little bit on all those abilities but don't regress on one of them. Like you don't go back, like you because you're training one model ultimately. So what will happen is, say, six teams are there, say math and code and browsing, like all of them will contribute some data, and they will say, okay, this data helped in this way. But then there is also a like a process of creating a curriculum, like this, like based on your current model, they came up with those set of like data mixes, and now you have to kind of mix them up nicely so that all of their hypotheses are retained, but your base mixture, like you will also have some base mixture that's ongoing that you trained your model on. So how to stably mix all of these, and the base mixture you have is kind of black magic kind of thing. I mean, it is theoretically grounded, but what works, what doesn't, can only be observed by doing this a lot of times, and each time doing this is itself possible only in such a setting. So this is okay. So whether this situation will persist, I think it will. I think one parallel you can take maybe is the databases. Maybe, like, I think this situation has persisted, but I think what will happen is there will be people with such high compensation, but I think what happens is, maybe as few players will get burnt out, and maybe some of this knowledge will propagate. Maybe the number of such people, like the number of such people will become less. I think though past is not a good indicator of the presence, because I think it also depends on how many of the like as we saw with coding, there are certain things that get uh, automated or pipelined via an AI. Like in this case, we are also discussing the effect of how automatable via AI plus other means the job of a research scientist itself becomes. I think it might, that factor might also come into play. One advantage AI research scientists have is this compute thing. Like the iterating on what they do, like if you want to actually train a research scientist agent which actually does this kind of post training, you would actually have to give it access to GPUs, and you are actually bounded by physical time there. Like it doesn't matter whether it's a human launching the experiments or an AI, the GPU resource has to physically run, like that whole parallel job has to run. And so the physical bottlenecking leading to more time, so you cannot really, like in Bench, for example, if you are training a LLM to code up a repo, or like search in a very like do customer service conversations, you can actually, since your simulated world is very fast, you can actually run like 10,000 experiments a day and like update the model. But you cannot run like this loop, like the time of the experiment here is actually tied to the time of the real world. So there is a real bottleneck kind of to that. uh yeah, okay, about yeah, so I don't I don't know whether I would make a prediction. Yeah, like I'm generally not a fan of making like predictions of such a complex process, maybe. Yeah, but I could predict some aspect, maybe if that's of interest. But yeah, I don't think I can make any coherent or well-formed prediction.
I would say a very in-depth response again, and it's very
Mm,
opening. And also, we can try and add in more parts to kind of define the terms.
sure.
A question I had was about, this was kind of like talking earlier about where you were saying was
you're talking about like the difference in AI and like the biases and stuff like that. I
Right,
wanted to talk about variability in the response of AI because like AI models don't always give the same answer to the same question. Why do you
right,
think there's so much variability in the responses? And what
right.
does that mean for how we use our systems?
Right. Yeah, that okay, so that's a good question. So I think there are two things here. One is language models, the way we sample from them. So language models are distributions, but we use them as samplers and actually technically so there you might have seen when you are using an API ever there is a temperature parameter you can set. I think GPT-5 has dropped it, and if you're just using chat and stuff, maybe you won't have seen it past 1 year. Like they try to hide it or something. Like it will be there in settings or something somewhere. But essentially, what this temperature does is, if your temperature is zero, your it is almost the model is almost. I will explain why the almost arises. The model is almost deterministic, but as a result what happens is the model can actually not end up like the model is also kind of less creative, so it has no so this when you have temperature zero, what's happening is the model is literally doing greedy decoding. Like for example, what happens is when you have a word distribution, and so this word distribution will have say 10,000 words, and maybe the top word will have probability 10 power minus 2, the next one will have probability 0.85 into 10 power minus 2, right? So if you are doing temperature zero, what mostly should I'll explain the almost. What will happen is it will pick the point 0.9 into 10 power minus 2 word, like you're doing. So this is why it's called greedy decoding, because you are picking the greedily the topmost one. There is also beam search which you can do, which I don't think most APIs support, but you can. So what beam search does is you actually pick the top 5, and then you extend these, and then next step you will, from the 5 you will expand 20 it to 25 and pick the top 5, and then like so there are many various, but okay. So this temperature is one thing, but as a result of keeping temperature zero, what will often happen is if you have tasks which require more creativity. So to give you an example, if you are solving a crossword which is actually uh, maybe in dimension maybe 5 times your New York Times crossword, or like a Sudoku puzzle, but not with 1 to 9, but 1 to 25, or like something like that. So a puzzle that involves lot of solving and lot of backtracking. Often what happens is okay, so if your temperature is zero, the tendency there is because models are ultimately uh, so models are ultimately pre-trained on finite pieces of text, right? So and with an end of state token, so there is a natural bias in LLMs to end. Like this bias maybe not at all visible maybe early on, but if you are actually doing an activity that involves a lot of reasoning, backtracking, coming back, going ahead, you actually need to allow the model to not stop. Like so what will happen eventually is, as I told you, this distribution will start having the end of state token on top, like after say 1,000 or something. So if you are still using temperature zero, you will always end up in this end of state. So you will try to solve a crossword. If it's very easy, okay, you will get the answer. If it's very hard, the model will be in some intermediate position and still maybe erasing what part of what it did and like still thinking, but then it will kind of have a tendency to say, okay, this puzzle is hard and EOS. So you do need in such tasks. So this is one set of tasks where the reasoning itself involves some amount of creativity and exploration. There are also other tasks which is like you are generating literally a film script. Like you want to generate, say, there is Zendaya and they are playing they are tennis players, and generate me a script which is like has a hanging ending or something, like a unresolved ending. So to generate such a script, you like here the task itself is creative. So you actually want to generate maybe 6 or 7 scripts, and you can, so with temperature 0 you will keep getting the same script. So if you want actually lot of creative variation, you actually need to up the temperature. Okay, so upping the temperature is necessary. So as soon as you have upped the temperature, you will you will see large so you wanted the variation, but you will see large amount of variation, because now what is happening is when you have temperature uh, point 3, what is happening is when temperature was 0, what it does is basically if you have this, what as I explained, like say 10 power minus 2, 0.85 into 10 power minus 2, it's kind of making this 1 0 when you have temperature 0. But when you have temperature point 0.3, it's more spread out. And you can think of the temperature. So when temperature is infinity, the whole world is kind of gas, kind of like the whole world is the sun. So temperature infinity represents full random. So this directly comes from physics, kind of, right? You might have studied it in some thermodynamics, that temperature infinity is like yeah. So when, so with temperature point 0.3, things will be more spread out. Of course, we don't increase temperature too much. That's why if you see LLM like APIs or setting tab in Claude or something, it won't let you raise temperature to infinity. It will block it at 1 or 2, because they don't want to you to explore that very very crazy, or like very very like after a point, or like after a point, all of the procedures you have done, like most of the training we do is at temperatures, it's on samples which are drawn at temperatures between 0, 1, 2 or something like that. Like you don't know what a model will do at that high temperature. But anyway, coming back to the point, so this temperature, the need to have a higher temperature for diversity creativity reasons or for exploratory reasons is what leads to non-determinism. And often in tasks which involve solving something long, like customer service or deep research, or generating a bunch of poems, or like writing 50 haikus uh, for some get like reunion or something, like such a task, you do actually need the higher temperature because you want a good long creative output. But that leads to variation. But okay, now I will come back to the almost part of things. So if you were actually doing this thing on a CPU, on the same CPU, exact same CPU, like your Mac OS manufactured in the last 6 months of 2024, you were sampling from a LLM at temperature 0, you will actually see the same answer again and again, like exactly the same answer. But when you actually do this over an API, and especially even if you have a GPU at home, like a cluster of GPUs, you will actually start seeing variation even at temperature 0. Like if you draw 100 samples, you will maybe see 70 of one type and 30. So the reason that happens is uh, uh, when you so the reason we use GPUs is they can do matrix operations much faster. And specifically, there is an operation which is, there is a particular kernel which is supported well on GPUs called, I think it's called GEMM, generalized matrix multiplication, which basically so your MLP is matrix multiplication, your attention, so a lot of the internal elements are matrix operations of various kinds. But the point here is that when you are doing it on a CPU, it is like it is slow, but CPUs are meant to be like, so that these operations, like you want your browser to kind of look the same when it's doing graphics or something. So so the basic so but when you are doing it on a GPU is literally a system built to do matrix operations very fast. And even I don't know the physics of why this happens, but when you are and a GPU is actually not one kind of CPU. A GPU actually is kind of like it will have 8 or 16 kind of these kind of blocks. And what happens is when you do matrix multiplication on a GPU, that matrix gets split into blocks. So instead of like instead of A transpose B, what's happening is you actually have a row, like you actually have a bunch of rows multiplied with a bunch of columns. And then so and the way there is non-determinism in these computations when they are and all of these are floats, right? So there is some kind of non-determinism or like because so what happens is when these operations are happening, there is lot of addition like you are multiplying floating point numbers, and ultimately the numbers you represent on any computing system, they are not they are not infinite precision, right? So you cannot actually represent pi on a computer because pi is infinite, so you will actually run out of bits representing it. So that is the reason both on CPU or GPU, the numbers themselves are bounded. So if you have a neural network which has like millions of floating point numbers going through, like maybe modern networks have 20 layers, and like you, that's why the models are B, right? Like there are literally 30 billion parameters, and these you have, and the activation size may, so you have the input embeddings, and embeddings become activation, so you actually have a lot of floating point numbers going through potentially non-deterministic operations also. And because of the way these operations happen, B, because of you can have like like for example, even A plus, like the way you do A plus B plus C on a finite precision system can actually, whether you do A plus B first and then do plus C, or whether you do B plus C first and then do A, that can actually change the answer. Because what might have happened is that you might end up into overflow and underflow potentially, like because and you then have to correct it. But yeah, so because it's so to just to contextualize again, I think the way I guess you, I mean, would it be fair to expect overflow and underflow? I mean, yeah,
Probably not. Could you really
yeah,
quickly explain it?
yeah, sure, sure. Yeah. So I think what happens is when you are representing, say you have 7 bits, right? So 7 bits is say 2 power 7 is 128. And now on these 7 bits, maybe you can represent minus 64 to 63, right? uh in terms of those bits, because like 0 minus 60, so 64 0 63, so that's 128 numbers. Now for example, in this system, if you added say 63 and 99, you would actually end up with like since you do this addition actually in bits, you would actually not end up with 162. You would actually end up with some negative number or something, because you will kind of cross over into. So now I don't know whether to call this overflow and underflow, but you get and so actually how floating point numbers are represented is a slightly different, like you will have a two-part representation where there'll be a mantissa, which is the part after the decimal point, and the part before, which I forgot what it's called. So we'll have two bit vectors, but there are more subtle kind of, these kind of overflows that will happen. And this is, and now this, with this you can better understand what I meant earlier by A plus B and B plus C. Like for example, like yeah, so for example, if I was doing 63 plus 99 minus 63 plus 99 minus 49, I need to avoid to, like if I do 63 plus 99 first, I will end up with some kind of, like this kind of overflow, and then I will have to do minus 49. So if I fix it, it might work a bit. But the safe way to do this would be to do 63 and then 99 minus 49. Like so you'll have 63 plus 50 and then 113. So yeah, so and so there are these two sources of, and but actually when you are doing this, like right now, because this was locally three operations, we could sequence this properly. But if you have many such operations, this becomes harder, and you are also doing this in parallel, so you will get different results based on how you schedule it, kind of, right? So this is the reason you actually, so now as you explained, you get a word distribution, right? Or whatever token distribution. As I said, you would have maybe 10 power minus 2. But what if when you ran the same thing, but because of this non-determinism, you have a flip? Like the, for example, you had, I want to go to the zoo, and so for example, zoo, I like wildlife and I want to go to the, and now you're thinking of this distribution. So the zoo and the sanctuary are really close. So based on how these operations went, sanctuary will come on top or zoo will come on top. And this non-determinism is totally different from the temperature one, but this also provides another source of non-determinism, and this can get amplified along with temperature, because in temperature what is happening is you are actually exposing the full distribution. So all kinds of flips in order that will happen in this distribution will start showing up in your different samples. And so these are the two sources which lead to non-determinism. And actually thinking machines, there is this blog post by Horace Hay, who used to be at PyTorch before and is now at Thinking Machines. I think they have found some way of reducing the non-determinism one. So this is very complex because it involves dealing with the CUDA kernels in some way, and like how the Python code that you write for the network, say in PyTorch, this actually via Python gets translated into C, and then the NVIDIA CPP or C kernels, which actually then dispatch it on the GPU, will handle it. So it requires actually changing PyTorch or something like Horace used to work on PyTorch, but because of lack of time, I have not read that article well. But I can link, yeah, like you will find it. Just search for Thinking Machines Horace, or like Thinking Machines blog post. Maybe one of the last 5 or 6 blog posts will have it. Like it was just 2 months ago. So this is a very important issue. It creates a lot of headache, because another thing I'll tell you is that uh, like often we use different libraries at during training and evaluation, or like when running a model and running a model to train on. So especially in RL, what we want is you are actually making a model play and you are training it on how it has played. Like you're training a model on online samples. So what we do is we take a framework which is much more optimized for running a lot of experiments, like running a lot of samples, and the training we are doing in PyTorch or something. But for this deployment, there are these libraries like VLLM, for example, which kind of, if you have Swebench, like I have this model, run it and get me 128 samples. It will do that much more efficiently. But what happens is, if VLLM is actually this VLLM is doing these optimizations, but as a result, they are actually touching the full stack down to how things get sent to CUDA. So the probability distributions you will get out of VLLM won't be the same as the probability distributions you will get out of PyTorch, like running your model in forward pass. And you have a loss function which takes in some means of those VLLM probabilities and some from your model. So what will happen is, you will like your RL objective will become kind of misaligned, or like incorrect. So you will see a lot of rage posting by people, maybe in second quarter of 2025, when they discovered this. And VLLM people have been working a lot on fixing this. But this non-determinism not only comes through, and it also is an issue for products, right? Because a lot of demos fail for this reason. Because normal code, you had this guarantee that it will work, as long as your Python version is the same, your OS version is the same, your processor is the same, and the internet works, your things work. Like this was the kind of the contract that people used to operate on. But if you have a LLM anywhere there, and especially with the second, and many people don't understand the nuance of temperature. So I mean, it's really hard sometimes if there are product managers, especially those with not a in uh, or like a complete on hand tech experience. Like they these like yeah. So actually, I've worked at ASAP, which was kind of a Series C startup working on building customer service agents for companies like JetBlue. And so we had both. Like it creates a lot of, and this was the early days of LLMs, like back in 2023. So GPT-4 had not yet launched. And we used to, like we literally, for example, used to have a repo which had like 300 examples of conversations, like a state in a conversation where a LLM and someone has talked, and from then on you will have the conversation play out. and we used to have certain LLM judges judging that conversation. And whenever someone would make any code change, as a part of those pull requests, a hook would run which would actually check, okay, we have changed this thing in our LLM driven pipeline, like either the LLM or how we sample from it or how we are constructing the prompt. As a result, are these conversations gonna maintain their outcomes in the exact same way? If not, you can't do this pull request. And so because we needed to have some guarantee to the PMs demoing our product to companies, that okay, they ask us to fix an issue, okay, we fix the issue, but we don't want to break something, some guarantee that you had. So yeah, it's a important, I mean, ongoing project to make this better. And I think at least autoregressive models are good because temperature equals zero preserves things. But if actually there are models where you fundamentally can't fix this, I think diffusion models, because they are fundamentally sampling Gaussians in some sense and generating so that is why in fact Midjourney does the thing it does. I don't know whether it does it anymore. If you have used any pure image generator, I don't mean like Gemini or Grok, like Midjourney, which used to be there in Discord. They used to generate four images, right? Like they given a prompt, it'll generate four images, and then you can pick the best one, because you like they themselves have that guarantee of good enough image only over a sample set of four. Like if you draw four samples, maybe you'll see good enough stuff, but you can't like distill it into one sample anyway. So that's the whole uh, non-determinism and why it arises, what can be done about it. Yeah, maybe it'll get better. Yeah,
Yeah, I mean, that's so much like valuable information. Like I can see like how again how passionate you really are about the subject. Like how would you say like you learn all this stuff, especially because these high schoolers who want to start getting into AI and these like different subjects, did
right.
you like have to have like a mentor or do you just research open databases? How would you say you get your information?
Yeah, yeah, that's a nice question. And I mean, I don't. So one thing is, I don't have lived experience of doing this as a high school student, but maybe to some yeah, like because the yeah, but putting myself in the shoes of one, I think one thing I would encourage, I mean, okay, so first thing is actual specifics of where to find this kind of stuff. I think reading papers is good. I think there are some good conferences, definitely, like NeurIPS is one, ICLR is one, but I mean, this is okay. I think there is also some good playlists on YouTube by, I think so. One is playlist by certain people like Andrei Karpathy has a zero to hero kind of playlist, I think. And there are also certain very good courses, but you should only take the courses because I mean, it's not that courses by other universities are bad or something. It's like if you take courses by Stanford CS, especially in this topic, like there is, I think, CS 224N, and there is also another course, I think, by, I forget, there's a course on like, so one thing I would tell people is whether in papers or whether you are going through any kind of video, always try to find the repos and the notebooks and try to do it yourself, because you can actually go down along, like you can fool yourself into thinking you understand something when someone who has actually done that thing is vibe chatting about it to you. But when you actually run the code and face issues, or like not just run the code, understand how the math, because one thing that is happens is that when you are working here in this kind of thing, the math, like the a lot of the papers won't have a lot of details, because uh they will be there in the repo. And like for example, not many papers will tell you uh which, like a lot of things will be in the appendix. For example, not a lot of papers will, if they have some, for example, some measure like a LLM judge based measure to check how commentator like, or how CNB, what is it, NBC baseball commentator like their comments were, if the task was comment generation, and they'll just say that okay, we used a prompt based LLM judge based metric, but they won't tell you whether they used temperature 0.3, or like they drew three samples and took average, and all of those things, and what prompts they use, how they put, like all of that might be in the appendix, or it might even be in their repo. And like the answer, due to this non-determinism that I mentioned, which like kind of permeates through the entire stack, like you, unless you have their repo and you try it out, the answer may even differ based on which GPU, like there, like okay, yeah, so there are a lot of things that are hidden this way. Okay, but coming back, so you should value resources that paired with them also have code. Of course, you shouldn't expect all the code to be there from the start, but the experience of taking some piece of running code, and then you should also try to like try to modify the code, like do something, think of something cool to do, and then actually implement that in the code. Another thing I would encourage people is to try not copy pasting code, like look at, for example, just go to Hugging Face and look at some of the models and their code, or like take like lot of the like OpenAI or thinking machines or Anthropic, or even there are a lot of open repositories, especially uh, by so okay, there are a lot of cookbooks like by OpenAI on how to prompt LLMs, how to build a pipeline, like how to build. I think there is Facebook has some repo on which has a notebook on how to create your own version of Notebook LM using Llama 3. So I would say, rather than watching six lectures, actually taking this code and actually running it, and then thinking of a simple idea like, okay, there's this podcast which I've managed to get running using APIs, or so that and yeah, when you're doing this, you will have to at occasion, like given the compute, and so you will either have to spend money or get a GPU sometimes, or like figure out some hack. But it's good to go through that labor also, because anything you do from here on in this field will have these bottlenecks. But coming back, yeah, so I would say to I think to pick up things, it's good to I think CS224N is one. There's also another one by Tatsunori Hashimoto, I think, who's a prof at Stanford. I think a course involving him. Let me actually see the name. Tatsunori Hashimoto. Okay, yeah, and I think there are some very niche resources for like reinforcement learning, for building environments, for benchmarks. uh, I would say, like, it's hard to say it in a word, like I can maybe communicate a list or something. There like, for example, just to give you an example, for environments and like benchmarks and like interesting solving kind of things for models, I think Open Thoughts has a reasoning gym, and like there is environments hub by Prime Intellect, and I think Facebook or a Meta Llama team also has an OpenEnv now. So I think though, so having a list of interesting repos to try and play out is also useful, but I think foundational courses are also important to some extent. And one thing I would say is uh terminology, like, yeah, lot of terminology is overloaded, so please beware of it. And like, you like, yeah, it's always, especially it's very good to have a first principles approach, like even if, like, like for example, you might have noticed this, like the first time you read a lot of novels, you would actually run over a lot of terms, like new words, and like not even think about what they are. But then later, when you had to give some examination, which is, or not some examination, when you had to actually use them, actually the specific meanings of those words mattered. But because when you were reading the novel, the context kind of got you through. So I think, if you're not, for example, if people are just saying LSTM and you don't know what LSTM is, actually go and look up what a LSTM is. And I think one thing you should do is, you can also use LLMs now to do this. But when you use a LLM, like ask it to maybe provide some kind of grounding of where, like, but you can actually get now you can actually mention sources because they have web access too. So but you can, like, for example, you can say I am a fifth grade dude who has done this. I have maybe this time, and I know these are good resources. I read this kind of news. I really want to understand this thing from and can you create in this next turn, can you create a plan for me? And then so you may not have time to go through a source, and you may have a certain skill level, but you can kind of use LLMs to shape that to form a kind of like a Duolingo, like your own personal Duolingo to learn that thing. So I think that is also, but beware of LLMs doing certain weird stuff while doing that. But I think that's a process. Yeah, I would say that I think each new like, because this whole thing is young, I think each new thing that becomes popular again will create another set of niche resources which people looking to learn that thing have to then go back and read. Like I had to in like maybe like in places like RL suddenly became popular right after 2022, and I had some context on it because, as I mentioned, my advisor, like Ravindran sir, who was like Balraman Ravindran, he was a student of Bato and a T at RL, and through him we had a lot of exposure on RL, and had actually myself neglected it, but I could very easily go back and find resources and refresh stuff. But to someone starting out and with a limited amount of time, finding that initial niche resource, like even to tell a LLM is kind of hard. uh, so there is always going to be, yeah. But I think one more thing I would say is nowadays people on Twitter or such forums like Reddit are very helpful. So if you explain your situation and are very honest that I know this, I don't know this, I want to learn this, can someone please help, and like I can look around, like please tell, like help me, I'm eager to learn. So people are generally helpful mostly. Yeah, I think that is what I would say, at least in general terms. I can, yeah, like I do know certain very very specific resources like for RL, but I don't know whether they can be like they're just, it's just literally the list of links. But yeah, anyway, yeah.
Yeah, no, definitely, Mr. Gungal. I would say your responses, your response you just had was definitely really helpful for especially high schoolers who want to get started, but also like people in college and maybe like post grad who kind of want to traverse into the AI field.
Yeah.
I first of all, I wanted to say thank you for your answer on the variability in AI responses. I think that definitely was helpful in understanding like why AI systems can act so unpredictably. That brings me to a question that I think everyone really wants to know and is wondering about, and it's kind of like the trending topic right now.
Right.
Uh, what are the dangers of AI? Is it going to be as dangerous as people might say or fear? Or is it something that we can control? And like, just how is AI going to evolve like 10, 15, 20 years down the road? And what's your prediction on that?
Yeah. So I think one thing is that yeah, like it's okay, yeah, the dangers of AI. I think okay, so one thing is I think more so have not seen such a large availability of this particular stack of abilities, or like available at such a good level off the cuff to everyone. And I think that's a good thing, but we don't like there is a lot of bias we have in most human societies about what is the gradation of work, right? Like people actually have somehow got into this mold where they value knowledge work as high, or place it on a higher pedestal in some way. That whole, like, those, like, there are some typical priors we have accumulated over the past 500 or 1000 or maybe 2000 or even 200,000 years. Some of them may get reworked because lot of the innovations that happened were in the physical realm before. So but I think one thing is that I am a bit wary of making predictions about a tech. So I think AI is definitely an interesting technology, but I mean, even Haber's process was an interesting technology and it has had effects. But what I mean is that you okay, so when you have a random process in which many entities are talking about and exchanging a thing and like iterating on it, it is not, I mean, this is not evolution, it is kind of evolution in some sense. So it is the like the in evolution what happens is the artifacts that are like the things that are the the products of that process themselves become factors. Like what I mean is, for example, if you take the parallel of evolution of life on earth, like today when we talk about species we will talk about niches, right? Like there are herbivores, or like when you talk about the Amazon rainforest you will speak about animals who live on the canopy and the animals who will live on the uh, tree roof line or something, like skyline or something like that, and the animals who forage or like are on the ground. But actually if you think about it, uh, before the Carboniferous period, and in fact even during the Permian period, the only thing that was there on the ground, although there were a lot of land animals already, there were only ferns basically. And in fact flowering plants themselves arose during the Cretaceous period, which was like between, I think, 130 million years ago to 65 million years ago. So the notion of there being a niche called herbivores, or like foragers, or like this class of animal, like which includes, I think, gazelles and okapis and wildebeests and stuff. Like we speak of animal species failing to fill a niche, but a new species can also itself give rise to a niche. Like for example, if suddenly we have, so okay, so coming back to the point, like there might be a lot of new things that might arise out of AI that might themselves become factors that makes it hard to predict. But uh like for instance, to give a parallel, I think if before the industrial revolution you had like in 1700 you would have even had someone thinking about say a LLM researcher, or maybe even a systems engineer, these professions might have sounded completely imaginary, and they have actually no basis in the artifacts of the time itself. Like it's not as if they could have predicted something about it. The whole context did not exist. What I feel is, I think it might lead to much more rapid iteration on certain things we are bottlenecked on, definitely. And I think it might, because certain things we value a lot may become commoditized, it might increase, it might lead to more churn, like exploratory, like okay, so this is a little bit my own beliefs. I think it might help humanity become more intentional about exploring the universe, or like expanding to other planets or something like that, because fundamentally a lot of the complex things to do on earth may have less doing, but like new things like exploring the ocean, exploring the universe, there things which people could not do so much because there was a gap, like now they can do little bit more, and there is more incentive to do exploratory things because the usual valuable things are less commoditized. But I think I went into a very economic and social answer to your question. I think your question, can you like can you restate your question? Like I want to just get into the other aspect also a
No,
bit.
no, yeah, that was actually really good.
Okay,
So
okay.
basically, overall, my question was, what are the dangers of AI and how it's going to evolve over the years? But I definitely feel you touched on the evolving part. Could you
Yes,
talk about
the
like
danger.
maybe
Yeah.
dangers or like checks and
Yes.
balances on AI?
Right, right. Yeah, yeah, yeah. So I think dangers are, I think one thing is that we are not used to having beyond our pets maybe, and beyond certain, I don't know, animals which are not exactly pet. Like maybe in India you have elephants sometimes you see in temples, or like on the street sometimes, and you feed a banana or like pat them. But we are not used to seeing other intelligences, like other types of intelligences, and interacting with them at scale. And because AI, because LLMs are actually talking to you in language, and they are indeed in some sense, maybe people are saying already, I mean conscious, and they are very capable, you might think of like you might come to expect to have expectation, like you might develop, because it is natural that if someone is talking like a human, you kind of think that it is a human. uh, they are very much human in certain aspects, but their methods of learning acquisition are very different. So for example, okay, one danger is that I think this is a manifestation of the somewhat extreme thought experiment called paperclip or whatever, that uh, which is actually kind of extreme. But like, if you have an AI system that you had a paperclip factory and you wanted to improve the production of paperclips, you it actually goes well for a while, but then that AI system actually takes over the whole planet to produce paper clips, and then there is no market to sell to, and like there's no universe anymore. So this is extreme, but the point is that there are a lot of unstated invariants and constraints that you don't even think of uh, as you don't even think of when specifying something you want to do. So underspecified objectives are a danger, kind of, because uh, what I mean is, so for example, if you have Claude Code and you have some legacy Linux distro that has some very specific like you have got Python. Okay, so you are working on Arch Linux, okay, and you have set up your terminal with a lot of difficulty, and you have got, say, Python 3.12 working with a lot of difficulty, and you have Claude Code running. There is some repo, and that repo has certain make files and stuff, and uh, you Claude Code doesn't know about, like, you forgot to tell Claude Code about this whole Arch Linux situation and how you got this OS running. This Claude Code, you tell it, okay, this is the repo, I want to understand and set up this repo, and I want to be in a position to make changes. What Claude Code will do with impunity, if the makefile says it as Python 3.13, is it will uninstall that Python 3.12 and like try to install, say, virtualenv, and then try to bring in Python 3.13. So the thing is that, okay, this was a very direct example, but there might be many such assumptions. For example, like deleting certain important files, or like it not knowing that your OS has a limit of 64 GB. So there are certain things which you are subconsciously aware of, but you don't state when you actually state the problem. So I think Andre Karpathy coined the term context engineering. So either your context engineering has to be rich enough for the model to discover these unstated constraints by themselves, or you have to specify them. Uh, but that definitely is one.
That's a wrap on part 2 of our discussion with Mr. Varun Gangal. His insights into model alignment and responsible evaluation shed light on what it really takes to make AI trustworthy and effective.
Join us next time for part 3, the season finale, where we'll explore the future of AI, the research frontiers ahead, and Mr. Gangal's take on where this technology is headed. Until then, keep building, keep questioning, and keep exploring your professional perspective.